So today, and then for the next couple days, we're going to be doing applications. So usually, or a lot of times, math is like, here's some problems and do it. Well, today we're going to actually, and for the next couple days, look at some applications. And today we're working with expected value. And we use this with warranties, spinners, tables of possibilities, and other real-world situations. So a little thing that will help us when working with these problems is PPAA, and it's kind of like the method of solving these problems. So first we find out what kind of possibilities. From a situation, what are our possibilities? And then we find out what our probability of those possibilities are, and times that by the amount, and then add. So this method is very similar for all of the problems that we'll see. And you probably did this in your homework too. So let's look at an example with Best Buy and a warranty. So let's say your little brother goes to Best Buy and purchases a CD player for only $23. The sales clerk is trying to talk your brother into buying a 2-year warranty on the CD player for only $1. Your brother doesn't understand what a warranty plan is, but it only costs $1, so maybe he should try it. If 1 out of 10 CD players go bad in 2 years, what is his expected value and what advice would you give him? So let's use that PPAA. So the first P is the possibilities. How many possibilities do we have? With this CD player, it can either go bad or it would be fine and not go bad, right? So let's use, what? Yeah, well, yep. So let's first list our possibilities, Kevin, but good. So it's either going to be bad or good. Bad means it breaks and you're going to have to use that warranty. So the next part is the second P, and that's the probability. So the probability of it going bad is what? 1 out of 10 or 0.1. It says right here, if 1 out of 10 CD players go bad in 2 years, and then if it's good, like nothing happens to it, that's 0.9, right? Like 100 minus the 10% is 0.9. So we've done our first P and our second P. Now the amount. We got to figure out the amounts. So if it goes, let's say it's good. Let's say nothing happens to it. What would our amount be? Does anyone know? Yeah, it would be just -1 because you spent that $1 on the warranty and you're not going to be really using that warranty, so you're out $1. And then if it goes bad, well, that's 23. How much you paid for it minus that $1 you paid because you're using that warranty. I sometimes think that getting these two numbers can be tricky. Is anyone confused on how I got those or why we're using those numbers? Okay, so then we found our amounts. Now we have to add them. So what we do is we take our probability, our 0.1, and multiply it by our amount, which is, in this case, 23 minus 1, or 22. And then we add that to 0.9 times -1. And can you get out your calculators and figure out what that value, what this comes out to equal? 0.1 times 22 plus 0.9 times -1. What does that come out to equal? Anyone typing that in? So first we got to do the multiplication and then we can add. Did you get it, Maddie? So tell me what we got in decimal. Oh, 1.3. Yep, so it's $1. Shh. It's $1.30. That's his expected value. So would you tell your brother to buy this warranty?
Yes.
I would say because, yeah, I would. Okay, any questions on that one? Let's move on to a different type of example. Each time you see your favorite uncle, he opens his wallet and lets you choose a bill without looking. Your uncle always has the same bills in his wallet. So, we're going to use our PPAA again. So, what is our possibilities? Possibilities would be you could reach in and grab a 20, a 10, a 5, or a 1. Those are our 4 possibilities. So I'm going to list those. And then what is our probability? So let's say I reach in. What is my probability of grabbing a 20? He has 1/20, so what would our probability of...
1/20.
Yes, and why is it 1/20th? Yep, 1 plus 3 plus 6 plus 10 is 20. So 1/20th of a chance of reaching in and grabbing a 20 out. Yes. So we can take that probability and put it in front of our possibility. 3 $10 bills, so there's a 3 out of 20 chance. 6 out of 20. And 10 out of 20. You already got it? So what is the answer? But that's not what I got.
No, that's what I got.
I got 6 last time I did. Is it 4?
I got 4.5 also.
Someone recheck it. Because I tried it and I got 6. Maybe I... I could have done it wrong. 4.5? Yeah. I guess I made a mistake. So $4 and 50 cents. So you would expect to get about $4.50 over time. What? Is there a question? Okay. Another one. This is a common one that you'll probably see on a test in the future. So, a college quarterback starts for all 4 years of his career. The number of touchdowns he threw during his first 3 years is listed below. So as a freshman, he threw 14, sophomore 23, and junior 31. So the question is, how many touchdown passes would he need to throw his senior year to average 25 touchdowns? So averages, let's say we have 3 numbers. Let's say we have 3, 5, and 7. How do we find the average of those?
You add them up and then divide them by 3.
Yeah. So if we want to find how many would he have to throw his senior year to average 25, what would we do? But we don't have a senior year, so would we just say like plus like X or any variable divided by 4 equals 25. So first we can multiply both sides by 4. What's 14 plus 23 plus 31? 68 plus X. Shh. So X is 32. What does that X in the context of this story mean though? What does X mean? X equals 32. He needs to throw 32 touchdowns his senior year to average 25 over his 4 years. Any questions on this one? Shh. Okay. Another type of problem. So, you're in a class, and your grade in that class consists of 85% of what you did throughout the quarter. And then the other 15%, that depends on your final test score, whatever you get on your final test. So, if you have an 82% going into the final, what would you have to get on the final test to maintain a B for the semester? So, does anyone think they can do it in their head?
Yes, I can. You would have to get 2%.
Well,
What is this?
let's look at how to solve it. So our grade in the class is made up of 85% of just like what you do throughout the quarter and 15% of your final. So if you have an 82% going into the final, then can't we say that 82 times that 0.85? What are you confused about? Well, this is how much he needs. 85% of your grade consists of what you do throughout the quarter. And he goes into the final with an 82%. So we need to multiply those to figure out. And then, so what does he have to get to maintain a B? So we need to figure out what percent on that test.
Don't you multiply 0.82 by 85? Because
Oh, it's commutative. Multiplication is commutative. So it doesn't matter which order you multiply something, you always get the same answer.
oh yeah. No, but that equals 100, right? So you multiply. Okay, never mind.
Shh. That's okay. If he's confused, that's okay.
Okay, but like, if you want that to equal 100 or whatever, just write the actual. Oh, are you gonna multiply the answer by 100?
Yes.
Okay, I got it.
So we want to maintain a B. So we'll set that equal to 8. What does x come out to equal? Can we solve this? Let's solve it. 0.85 times 0.82. What is that? 0.697. Did anyone get what x equals? So 0.686, you said? So now you're right, Sonny. We have to multiply that by 100 to get it into a percent. So 68.6%. So he could get, is that like a D plus? He could get a D plus on the test and maintain that B, which I think is pretty crazy. D minus? Shh. Nope. This percent is X. So that's telling us what he could get on the final to. Nope. If he got this on the test, if he got anything lower, then he wouldn't be able to maintain that B. Oh, but the answer is a 68.6. So that's about a D plus. Does that answer your question?
But you would have a B minus, like, overall, then. That's what she was trying to say.
Oh, yeah, I realize what she's trying to say, but this is saying that if she gets 68.6% or higher, then he maintains that B. It is. It's just a hypothetical. It's not for this classroom. Is it? Oh, so it's so they mean they're worth less. You failed it and got an A?
Yeah.
See, that's kind of weird. Okay.
Just
I want you to try this one on your iPad. Shh.
Sonny, shut up.
I want everyone to try this one. If you have an 82% going into the final, what do you have to get on the test to stay out of the D range now?
Way to aim low.
Try this one. How would you set it up?
I'm gonna go about 40%. The least you can get here is 50.
Yeah. But just, this isn't for, yeah. Try this one. Try this one, John. Try this one.
You might have set the other one wrong because the finals are worth 10% of your choice.
Oh, this is not for this school. This is just like a problem that I made up. Okay. Yeah, that's kind of ironic. Okay, shh. So, okay. So your grade in the class is made up 85% of the quarter and 15% of the final. Yours, at the end of this quarter, before the final, you have 82%, and we're still trying to find what can you get on the final test. So we set that equal to 0.7. And if we did all the math, you should have gotten it to equal 0.02 or 2%, which means that you'd only have to probably get, I don't know how much the test would be out of, but
One question.
yeah, maybe 1 to 2 questions. And you would still be able to, but a D, that's not,
I'm gonna do it.
that's not shooting.
70%. You're getting a C minus. Barely. I got 1.3. You're not going to college though.
So they're saying the D range.
C is an average. C is college.
So 2%. It's kind of crazy. Let's look at this last one. If I have 82% going to the final, what do I have to get on the test to get an A? So the same setup. How would it be impossible? Oh, let's solve this one. Yeah, I know where you're going. And once you get this, raise your hand and let me know you get X to equal. Joe, what'd you get? 135.3? Okay. So, did anyone else get 130? Or did they get 135.3? Okay. So, 135.3% on the final. Is it possible?
Yeah,
If there's extra credit. Otherwise, yeah, that would be a lot of extra credit. So, realistically, he probably wouldn't be able to get an A in the class unless the teacher put a ton of extra credit on there. Yeah, and then they'd have to get everything else right too. So that means they'd have to get all the extra credit and yeah.
They studied a ton.
Yeah. But if there was no extra credit, then it would be possible, right? They wouldn't be able to do it. Okay. So, let's do one more problem. So you want to buy a calculator that costs $125. 9 out of every 100 goes bad in the first year. So they offer a warranty of $15. And we want to find the expected value, but now we also want to figure out, should you purchase the warranty plan? Should you buy it? Like, would it be a good idea? So let's set it up. With this calculator, there's two possibilities, right? It can either stay working or it can, yeah. So this is good or bad. So if it's bad, 9 out of 100 go bad. Shh. If it's good, that's about 91 out of every 100. So if it's good, never breaks, you're out 15 bucks. Because you paid for that warranty, but you didn't actually use it or utilize it. And if it's bad, our calculator was 125 minus 15. Yep. So this is really 110. So if we want to figure out what the expected value would be, we'd say 91 out of 100. Our probability for it being good times our $15, our amount, added to 9 out of 100 times 110. What did you get that to equal? Shh. What did you get it to equal? 3.75? Yep. So, the expected value is negative 3.75. Good or bad idea to buy that warranty? No, you would not want to buy this. I mean, warranties probably sometimes are a good idea, but in this case, the company is making more money off of those warranties. So the expected value is actually worse. Yes. So probably if you were buying a mass amount, maybe.
400. You should buy warranties on.
Okay. Any questions on that one?